Hello and welcome. My name is Connor Dales, and today I will be giving a presentation on the analysis of data provided by the World Value Survey, in which a global data collection conducted to obtain data on varying political topics to achieve a statistical understanding of what this data means. Using this data, I will explain how it was analysed through the use of varying data models, which include the univariate and bivariate models. Inferential and descriptive statistics will be explained with examples included also. The World Value Survey data analyzes patterns and perhaps any anomalies within varying groups and participants by using interval and nominal variables. An exact number within the data can be achieved, as well as a number of bivariate tests. Theories associated with the data provided are also taken into account as a way of explaining such anomalies or interesting patterns in data through non-numerical evidence, but instead providing a sociological perspective. The World Value Survey is conducted to measure how changes within society and their surrounding environments have affected them. The World Value Survey states that in order to monitor these changes, the EVA/World Value Survey has executed six waves of surveys from 1981 to 2014. This level of data collection can provide an extremely wide range of data and in turn displays a number of patterns in certain periods of time. The variables I have chosen include V235, sex or gender, and V253, scale of pay. They are both chosen in order to establish which sex actually achieves a higher mean wage. These findings allowed are linked to theories and effects in order to present the data in a sociological form or explanatory form for those less able to interpret such statistics. Using tables and graphs and the measure of central tendency, a descriptive analysis with an inferential analysis was conducted using both univariate as well as bivariate data. Using V235, sex or gender, a descriptive test was conducted in order to create a frequency table, Table 1, which presented the measure of central tendency, in this case, mode. The mode was 52.2% within the female row, therefore explaining the females were the most dominant with regards to test participation. Table 2, however, displayed the median, 2, and mean, 1.52, also, which presented the other central measures of tendency. Presenting this information for those unfamiliar with statistics is conducted simply by displaying the frequency table, Table 1. However, presenting the information through inferential analysis had to be conducted through a binomial test of significance, Table 3, which was completed using the only two variables, male and female. The observed proportion column indicates that 0.52 or 52% of participants were females. The exact sig-2-tailed column is at 0.000, so we can be sure our results have a limited chance of being affected by sampling error. Simply put, the number of participants were predominantly female. The exact sig-2-tailed reinforces that our data is correct. Now, scale of pay, or V253, was tested also with the same factors apply. The scale of pay, or V253, has been tested also. However, because it is an interval variable, there were different ways to test these variables. The measure of central tendency was not mode but instead mean, which was 4.60, shown in Table 4. With a minimum of 1 and a maximum of 10, this was part of the descriptive analysis associated with univariate data. There was a standard deviation of 2.278, which was the measure of central variation, and this number suggests that the data was not widely spread but rather close. Table 6, however, presented a mode of 5 and median of 5 to display all measures of central tendency. The inferential analysis involved a one-sample t-test, Table 7, where the mean is compared, but the mean difference was 4.598, which is rather close to our previous mean given. Nevertheless, a confidence interval was given between 4.58 and 4.62, which gave a 95% confidence in our mean and/or data. To display our given data different to the sex or gender frequency table, a histogram was formed to present the interval data. This positively skewed graph indicates that a large number of people received the same scale of pay, around the 4.60 mean average. Therefore, if the average of scale of pay is 4.60, both males and females should be similar. If not, then there is an inequality between the sexes in scale of pay. Now, bivariate data. The bivariate data consists of both sex or gender and the scale of pay variables. The same test will be used in order to establish a nominal and interval variable test result. A descriptive analysis test consists of an eta test, which determines the dependent variable or variable that is modified as a result of the other variable. In this case, the dependent variable was scale of pay, with the independent variable sex affecting the scale of pay. A value of 0.043 for sex in relation to scale of pay at 0.038 proves that this suggestion, however, there is not a drastic gap between the two variables. The eta test, Table 8, is displayed simply through the table it is created in. An inferential test was conducted, an independent t-test, which is different to the one-sample t-test conducted previously in the univariate data. A t-test, or independent t-test, Table 10, is used to compare data, in this case, male and female scale of pay. Is there a difference? In the independent t-test, because our sig level is above 0.05, we needed to look at the top row of the table, where equality of variance is assumed in this case. Because the sig2 tail column is at 0.000 and below 0.05, we can reject the thought that these mean scales of pay are a result of sampling error. Although there was little difference within the independent t-test, the group statistics table above presents a mean for both males and females, a mean of 4.69 for males and 4.51 for females, which again links to the glass ceiling effect. However, also seen is that the male scale of pay is actually above the 4.60 mean, where the females at 4.51 are very much below. The gap in data between the two means is quite large and prevalent in the contrasting type of test, t-test. Linking the data to theories. There are many theories from various fields of study associated with the patterns within this data. Strain theory, associated with criminologist Robert Merton, states that strain consists of a struggle between means and goal. In relation to data given within this presentation of sex or gender variable, in previous history would have had a large part to play when associated with the inequality of scale of pay. Therefore, the notion of a glass ceiling takes part where women in similar positions to men receive less pay and therefore resulting in a struggle to achieve a certain goal, creating a strain. In conclusion, the World Value Survey data given to analyse has provided some reasonably testable data, especially when presenting the scale of pay difference between male and females. A number of univariate database tests were conducted through descriptive analysis and inferential analysis, which included frequency tables, binomial tests of significance, and one-sample t-tests and histograms. A number of bivariate database tests were also conducted, such as an eta test as well as a t-test, independent t-test, which both interval and nominal variables were tested. Coming from a criminology background, I knew strain theory was an appropriate theory to link back to the tested data in order to present how gender has evolved and as that has happened, the equality in scale of pay. With reference to the glass ceiling effect associated with women in the workforce being restricted from going any higher because of inequality, is the main social component which has affected this data. Thank you.